Assalamu alaikum. How are you, my dear students? Hope you will be fine and okay. I welcome you all into my today lecture. Our today lecture is about the expansion of liquids. So let us start with the name of Allah Almighty. Now, what is the expansion of the liquid? Expansion of the liquid is the increase. Expansion of the liquid means that increase in the volume of the liquid, increase in the volume of the liquid due to heating, due to rise in its temperature, due to rise in its temperature. Like solids and gases, liquids also expands on heating and contract on cooling. So when you when you heat the liquid expands, and when you contract when you cool, the liquid contract. Now, what are the causes of this expansion of the liquid? And then I will come back to the type of the thermal expansion of the liquid, because you know that the molecules of the liquid, molecules of the liquid, the molecules of the liquids are free are free are free to move. They are free to move. Now, you know that when we increase the temperature of the liquid, the internal energy of the molecule of liquid increases. Increase in temperature, increase in temperature increases increases the increases the vibrational motion of the motion of the molecules of that liquid. Now you know that, look, when the molecule, for example, look, if this is the any water molecule, and if normally if it vibrate with this sort of the vibration, then when its temperature is increased, the internal kinetic energy increases, and they starts vibrating with a larger amplitude. So that when the amplitude of the vibration become large, the molecule pushes each other and need more space to occupy. That is, the amplitude of vibration increases. This increases the amplitude of the vibration of the molecule increases, and they push on each other, and they push on each other way, needing more space. What? They needing more space to occupy, right? This is the cause or the result of the increase of temperature on the liquid. To explain the expansion of the liquid, we will explain this by introducing you to two kinds of expansion. One we call the apparent expansion. Now, what is the apparent expansion of the liquid? The apparent volume expansion. The apparent volume expansion. Now, what is the apparent volume expansion? It is the expansion. It is the expansion in the volume of the liquid without the expansion of the vessel. Without the expansion, without the expansion of the vessel or flask in which it is kept, right? This apparent expansion is denoted from A to C, that is in the graph or in the diagram, it is denoted by AC in the graph, right? This indicates the apparent expansion. This indicate what? The apparent expansion. Now let us see it how, and contrary to this, there is another expansion which we call the real volume expansion. I will write and then I will explain to you the real volume expansion, the real volume, yeah, volume expansion of the liquid, volume expansion of the liquid. In this kind of expansion, the it is the expansion of the liquid. It is the expansion, the expansion of the liquid along with the expansion of the vessel. Usually in the lab we use beaker or like beaker made of glass. The expansion of the vessel is called the real expansion, the real expansion of the liquid. In the graph, it is indicated by, it is indicated by the line BC in the graph, by BC. Okay. So now let us explain it here. As you see, look, first of all, when you add heat energy to the, when you add heat energy to the liquid and the long neck flask or in the flask as you see here. So when you heat it, the temperature of the molecule of the liquid increases, and you see that this, the point A, where this is the initial position or volume of the liquid. in the flask before the time of heating. So once when you heat, instead of increase in the volume, there is suddenly drop. The point B indicates before a drop in the volume, drop in the volume. Actually, this is not the drop in the volume of the liquid. It is not that upon heating the liquid contracted, but there is another reason. As you see that the liquid is kept in the glass, and it is the glass flask which receive the heat first. So upon heating the water in the glass expands first, and when the glass expands, the glass expands first. So when the glass expands first, then what happens? Volume increases. Volume, its volume increases, and the level of the water drops because of the increase in the volume of the flask, right? So this actually from the point A to B, this A to B expansion, in fact, from A to B, this is the expansion of the glass, expansion of the glass without the expansion of the liquid. So this is why first the liquid drops. Now once it achieve its constant level of expansion, then when you increase the temperature of the liquid further, then the liquid start rising, attain the previous volume first, right, point A, and then it start increasing, and that is what we call the apparent expansion of the liquid. Why? Because you or anyone beside you will actually notice the total expansion is from A to C. Why? Because A was the already initial position of the volume of the liquid in the flask, but in fact the liquid first dropped. The liquid did not rise from the point A to C, rather it rise from the point B to C, right? So this is why we call this as the apparent expansion, and the real expansion is actually this expansion from B to C. The expansion from B to C is actually the real expansion from B to C. This is actually the real expansion. Why? Because that the liquid actually moved or shifted the volume from the B to C. So this is the real increase in the expansion of the liquid. So to explain it further mathematically, we write that in fact the real expansion of the liquid, the real expansion of the liquid must be the sum of the two expansion, the expansion of the flask first, expansion of the flask, the glass flask, less the apparent expansion of the liquid. The apparent expansion of the liquid, of the liquid. So the real expansion of liquid is the sum of the expansion of these two. So here, as you see in the graph, the real expansion is from B to C. This is from B to C. And the expansion of the flask is from A to B. It is from A to B, plus the apparent expansion is from A to C. It is from A to C. So to write it more comprehensively, the expansion of the volume of the liquid taken into consideration, the expansion of the container is also important. And when we add it, then it will become the real expansion of the liquid. And we, in terms of their coefficient of thermal expansion, we will write it as beta, volumetric coefficient of thermal expansion, Br, and it will be equal to the Bg, the volumetric coefficient of thermal expansion of the glass, plus the apparent expansion of the liquid in the glass. So this is called the the this is called the real rate of volume expansion, real rate of the volume expansion, volume expansion, the real rate of the volume expansion, right? And this this is called the apparent rate of volume, the apparent rate of the volume expansion, of the volume expansion, right? And this is the rate of the glass expansion, volume expansion of the glass, rate of volume expansion of the glass, yeah, volumetric expansion of the glass. So you see, this indicates that the the real rate of the volume expansion is always greater than the apparent rate of the volume expansion. You must note down this. The another important point, okay, I will come to that one. The expansion of the real rate of the expansion of the liquid can be defined as the actual change in the volume of the liquid per unit rise in temperature. The actual, it is the actual, it is the actual change. It is the actual change in the unit volume of the liquid, the unit volume of the liquid, of the liquid per unit rise in temperature, in its temperature. So that is known as the real rate of the volumetric expansion. Okay, so that is all about the real expansion of the liquid. Remember that the different liquids, different liquids, different liquids have different rate of volume expansion, different rate of volume expansion depends upon the nature of that liquid, depends upon the nature of the liquid. So this is for all today, and this was the last topic of the chapter A, thermal properties of matter. So inshallah in the next lecture I will focus on the exercise which include the MCQs part and the numerical part. So that will be an end to this chapter inshallah. So the last lecture will be the exercise. Thank you very much for being here today, right? So see you in the next lecture. This enough for now.